So hello guys, so today our topic is durability. So earlier in our lectures we have studied atomicity, consistency and isolations in the acid properties. So the last one is the durability, so we'll talk about it today in this lecture. So what this durability is, so whenever a transaction is committed in database, whenever you commit any transactions, the database promise, okay, whenever you commit any transaction, the database promises that the data you wrote, right, will not disappear even if the server crashes. So what exactly means? So whenever you are committing any data, right, so while after your commit, okay, if the server crashes also, right, if the server is crashed, right, but DB will give a guarantee that your data which you have written through this commit message will never be go out, will never be forgotten, okay. So what is saying, when a transaction is committed, the database promise that the data you wrote will not disappear, okay, even if the server crashes, power goes out or the DB process dies immediately after. So what that means? That means durability in this acid properties confirms you, right. So after you commit, right, the data will never be forgotten, data will always return to the disk, right. There is a physical disk. So at the time of commit, even if your power goes out, even if any crashes in the server, your committed data will never be disappeared, okay. This is what the durability promise from our relational database, okay. You got the point? So how it happens? So once you commit your changes, that time the database pushed the changes to the form of non-volatile storage. So what happens, that when you commit any particular database changes, so after the commit happened, right, so it will be written in any non-volatile storage. Non-volatile storage means disk, wall locks, redolocks, okay. So disk is the hard disk, right, upon which the database is working on. Locks are the intermediary non-volatile storage that we will talk about, okay. So how exactly relational database gives the promise to you of the durability? So there are two things that they do, okay. So if this after you commit something, right, before this message, before this particular changes pushed to the original disk, right, what happens, it gets written to the write ahead lock, okay. So you see write ahead, write ahead lock. So that what that means, by naming only you can see before the write, it actually preserves all the changes in a sequential manner in these particular logs, okay. So what happens, after the commit, before it is actually written to the disk, it is written in a sequential manner. Whatever changes your database is going to be it is going to be written in intermediary non-volatile storage, that is the wall log or write ahead log, okay. You got my point? So after what happens, from these wall logs, right, from these wall logs there is a flush event happens, and this flush event happens to disk, okay. So all the changes get flushed to disk, okay. So you understand the process. When you commit any particular changes, it will first go to the write ahead logs, but or redolocks, you can see. Redolocks is the logs which is why I am talking about two logs, right. One is write ahead logs. Write ahead is a generalized form. Redolocks is the one of the write ahead logs that is getting used by mysql DB, okay. So once you commit any changes, it will be written to the write ahead logs in a sequential manner, okay, 1, 2, 3, what are the changes you are going to have, okay, and from there it gets flushed to the disk. So in between, okay, after it is written to the write ahead logs, even if it doesn't return to the disk yet, right, if any crash happens, right, so what database does, right, when you restart your database next time, right, it will make a sync, with your write ahead logs to the disk, okay. So this fsync happens. What happens? This fsync happens, so it will give a sync to your database with your write ahead logs. So what happens? It replaces all the write ahead logs executions. So in the write ahead logs, it actually maintains in a sequential manner what are the changes the database has been going through while you committed the the transactions. So it replaces all the statement once again and rebuild your table, okay, so that your committed transactions appears correctly, so that your committed transactions appears correctly. You got the point, right? So there is another process, right? In distributed systems, sometimes what we do have master database and slave database, that means replica database, where this master is handling only write and this replica handles only the read portion, right? So what happens in distributed system, they may require the data to be stored in multiple nodes before coming. So what happens here, we have seen it is actually working with one node, right? But sometimes in distributed system, any commit happens, right? Any commit happens, it might require to write in multiple nodes, due to replications, right? So this is also another process. So whenever the data gets data is there in multiple nodes, if any of the nodes having the data, right, so it gets synced to the other nodes, right? So that's how also it confirms the durability. So this is it for today. At least we confirmed the relational database provides you the ACID property, where atomicity it provides, consistency provides, isolations provides, durability provide. So these are the best beautiful things that transactional database actually relational database actually provides you, okay, as an advantages of using this relational database, okay. So this is it for today. Thank you so much for watching this video.